This video is recorded to help my students to understand how to test a claim about population mean when sigma is unknown. There are 6 steps to follow. Step 1. Identify that all conditions are satisfied. There are 2 conditions. First, sample is simple random sample. Second, population is normally distributed or sample size is greater than 30. Step 2. Identify to use normal distribution or student t distribution. When sigma is known, we use normal distribution. When sigma is unknown, we use student t distribution. Sigma is the standard deviation of the population. Step 3. Identify the null hypothesis and alternative hypothesis and connect them with the claim. Step 4. Calculate test statistics. Step 5. Calculate p-value if we use p-value method or calculate critical value if critical value method is used. Step 6. Make a final conclusion. Basically, if the p-value is less than significant level, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Or if the critical value compare with test statistics, if its test statistics falling out the critical value, then we will reject null hypothesis. Otherwise, we fail to reject null hypothesis. If the claim is H1, alternative hypothesis, reject null hypothesis means that there is sufficient evidence to support the claim. Fail to reject null hypothesis means that there is insufficient evidence to support the claim. If the claim is H0, well, your book says this is a rare case. We should refresh the claim so that claim is always H1. But sometimes people make claim is a null hypothesis. So you reject the null hypothesis means there is sufficient evidence to warrant the rejection of the claim. Fail to reject the null hypothesis means there is insufficient evidence to warrant the rejection of the claim. So let's see 3 examples. First example. Assume that the simple random sample has been selected and test the given claim. Use the p-value method to test the hypothesis, identify the null and alternative hypothesis, test the statistical p-value, and state the final conclusion that addresses the original claim. The problem is this. The ages of actresses when the one are acting a word is summarized by the statistics n equals 78, x bar equals 35.2 years, and s equals 11.7 years. Use a 0.01 significance level to test the claim that the mean age of actresses when they win are acting a word is 34 years. So, first, we need to identify what is the null hypothesis and what is the alternative hypothesis. So the null hypothesis is the one always contain the equal mean. So for this one, this mu average age is equal 34. That's null hypothesis. So the average age not equal 34 is the alternative hypothesis. Then you will say if it's two-tailed test or not a two-tailed, left tail, right tail. For this case, you need to look at the alternative hypothesis. If alternative hypothesis is not equal, then it's two-tailed test. Now, you look at two-tailed test, you either will calculate the critical value, which is the t-value, such that the two tails area together is the significance level. That's your critical value. Or you calculate the p-value. P-value is the area outside this test statistic. So you calculate test statistic first. You calculate one, you will opposite is another one. So two-tailed test is the p-value is the area outside this test statistic, the sum, these two tails. So calculate p-value, you will use this formula. P-value equal t dot distribution dot two-tail. You put a test statistic here, put a degree of freedom here. Okay, you can calculate the critical value, you use this formula. So based on that, we first type in alpha equals 0.01, then we test statistical calculation is this. I will use x bar minus mu, since my x bar is in C14, mu is in C15, then divide by S, which is in C16, divided by square root of sample size, which is in C13. So I use this formula to calculate the test statistic. Based on that, I could calculate the critical value. So critical value is you give me the significance level, which is 0.01 in C18, degree of freedom, which is size minus 1, that's in C13. So I calculate the critical value. Now, once you have critical value, then you can already make a conclusion. You compare with test statistics. Your critical value is 2.64, for example, around here. Then this one will be negative 2.64. Then your 0.905 is in the between. So it's not a rejection area. Rejection area is here. So in that case, we make a conclusion is we fail to reject the null hypothesis. If you fail to reject the null hypothesis, since your null hypothesis is your claim, so you should say there is insufficient statistical evidence to warrant the rejection of of your claim, which is the claim about the mean age of actresses when the wing acting award is 34 years. Now, we also can use p-value method. P-value method, you need to calculate the p-value first. P-value is the area of these two tails you add together. Those two tails are the tails out of this test statistic, right? So I will use t dot distribution dot two tail. The first argument is my test statistic, which is in C20. The second argument is my degree of freedom, which is C13 minus 1. Okay, so now this p-value is much bigger than significance level. So with bigger p-value, we fail to reject the null hypothesis. Again, we make the same conclusion. There is insufficient statistical evidence to warrant a rejection to the claim that the mean age of actresses when the wing acting award is 34 years. Okay, now let's see another example, which is left tail test. Assume that a simple random sample has been selected from a normally distributed population and test the given claim. Identify the null and alternative hypothesis, test the statistics, p-value, and state the final conclusion that addresses the original claim. A safety administration conducted a crash test of child booster seat for cars. Listed below are results from those tests with the measurement given in the HIC, the Standard Head Injury Condition Unit. The safety requirement is that the HIC measurement should be less than 1000 HIC HRC. Use a 0.05 significance level to test the claim that the sample is from a population with a mean less than 1000 HRC. Do the results suggest that all of the child booster seat meet the specified requirement? So the data is listed here. Okay, now let's see. First, we will see what is our claim. Our claim say is less than 1000 HRC. So the mu is less than 1000 HRC. That's your claim is your alternative hypothesis. So your null hypothesis is the one opposite it contain the equal mean. So we just say equal 1000. Of course, you can write it as greater than or equal to. Now, so this will be one tail test. Actually, is left-tailed test. Okay, how do you do left tail? Because this have less than this notation here. So my n will equal all how many data here. Well, you can use count. You from this cell to this cell. That's how many data you have. Count total 6. Of course, for small data set, you can directly count, but I would like to use Excel formula in the case the data range is very big. Now, this mu is what I will test against the two, which is 1000. X bar will equal average. You click on average, then you get this data range. And your S, you equal standard deviation for the sample. You click on here, then you go through this data range. Okay, then you have standard deviation. Now the alpha is given, which is 0.05. And the test statistic again will equal your x bar, which is E15, minus mu, which is E14, divided by S, which is E16, divided by square root of sample size, which is in E13. Okay? So this gives you test statistic. Now, then we will calculate the critical value. Again, this problem did not require you calculate critical value, but I still show you how to do that. So calculate critical value, you will use T dot inverse, then you give the probability, which is your significance level, 0.05, and the degree of freedom is E13 minus 1. So that's your critical value. You can say your critical value is here, which is the one mark his left tail. The area on his left side is 0.05. Critical value is here, but your test statistic is greater than critical value, which is in this about this place. So it's not a rejection region. Okay, so we failed to reject null hypothesis. If you fail to reject null hypothesis, that means you do not have sufficient evidence to support the claim that all of the child booster set meet the specified requirement. That is the HSC less than 1,000. We don't have that. Okay. Now you also can use p-value. So the p-value method, you can do this. P-value will equal, you use this method, distribution, p dot distribution, give test statistic, which is in E20. Then give me you the degree of freedom. Degree of freedom is C13 minus 1. No, E13 minus 1, I'm sorry. Then cumulative. Okay, this gives you 0.07. So you have large p-value. The p-value is greater than significance level. So large p-value fail to reject the null hypothesis. So we will make the same conclusion. There is insufficient evidence to support the claim that the HSE measurement is less than 1,000 HSE. Okay. So last example is similar to your activity 6, problem 3. It has been claimed that the mean M span of adults in the US is greater than 165 cm. Does the data of our statistic class listed here support or contradict this claim? Justify your answer through a formal hypothesis testing procedure with a p-value approach using a significance level of your choice. Calculation and interpretation of the p-value is required on this problem. Give your final conclusion below. Okay, so we first list out our null hypothesis or alternative hypothesis. So null hypothesis, alternative hypothesis is greater than 165 because that's your claim, right? You'll say the average arm span of adults in US is greater than 165. So that's alternative hypothesis. So your null hypothesis will equal 165. Actually, it's less than or equal, but we just say equal. So this is right-tailed. Okay. Now the n, how to calculate n? Equal count. So I need to drag the data range. It's here. Okay. So I hit an enter K, 75. Then the mu is 165. I test against 2. X bar equal average. So I click on average. Then drag down the data. Drag down the data. Okay, to here. Okay, then hit an enter K. Then I will say standard deviation equals standard deviation, which I use this one, double click, then drag down this. Okay, it's here. Then hit Enter key. Now, that's the standard deviation. Now, my alpha. Alpha is up to your choice. Let us, for example, I choose 0.01 significance level. Then I need to calculate the test statistic. I call test. Okay, this test statistic will equal x bar, which is f14, minus mu, which is f13, then divide by s, which is f15. Oh, I forgot to type equal. That's why don't show up the cells. Okay, that's how it goes. Now it's good. F14 minus F13 divided by F15, right? Then this I want to divide by square root of n, which is F12. Okay, that's my test statistic. Now, based on that, I want to calculate p-value. P-value uses this formula since it's right tail. How do you know it's right tail? Because mu greater than 165 is your autolytic hypothesis. If this is greater than in autolytic hypothesis, you use right tail. Right tail, so my p-value will equal t dot distribution dot right tail. So I need to give you x, which is my test statistic, which is in F19, and the degree of freedom, which is F12 minus 1. Okay, so that's my p-value. Look at the p-value is 0.004, very small, less than your significance level. So with small p-value, we reject null hypothesis. If we reject null hypothesis, which means there is sufficient evidence to support the claim that the mean arm span of adult in US is greater than 165. If you have any questions, please give me an email.